Hi everyone. Today I will give a short presentation on a short review of micro laser ablation propulsion technologies for in-space applications. Here is the roadmap for today's presentation. Firstly, I will give a brief introduction and background, and then I will explain the basic working principle of micro LEP, and then I will explain or discuss the evolution of the state-of-the-art technology of the micro LEP propulsion, and also I will give a brief comparison of the performance metrics across all in-space propulsion technologies. And as a conclusion, I will list down about 3 commercial companies involved in LEP. Before proceeding on, it is first best if we know what is in-space propulsion technologies and its different categories. So in-space propulsion can be categorized according to the basic principles of generating thrust. Is the thrust generated instantaneous, or is the thrust increasing over a period of time? Laser propulsion is a form of electric propulsion, and electric propulsion is a form of non-chemical propulsion, as can be seen here. Now, within the electric propulsion group, there is the laser propulsion. Laser propulsion can be categorized into 2 types: photonic laser propulsion and laser ablative propulsion. And our focus for today will be laser ablative propulsion. For photonic laser propulsion, laser is beamed from a source and the photons, which have energy and momentum, will be bounced off of a spacecraft with large reflective mirror due to produce motion. But this is not our focus for today. Our focus for today is on laser ablative propulsion. The earliest concept of laser ablative propulsion was suggested by Askarian in 1963. However, it was Kantrowitz who understood the phenomena better in 1972. So how is laser ablative propulsion generally occurs? Firstly, plasma is produced when high-intensity laser beam interacts with an ablative target material. Ablation occurs and plasma is generated. A series of combustion then occurs when laser beam continues to interact either in pulses or in continuous mode. Let me explain now the basic operational principle of micro LEP. Why do we choose micro LEP? Because micro LEP has potential to be used for small satellites, example information flying. So there are basically 2 main components of micro LEP. First is the optical system, which consists of laser beam source and the lens, and second is the target material. There are 2 different modes of which micro LEP can operate on. First is the transmission, or also known as T mode, and second, reflection, or also known as R mode. So what happens is that laser beam goes through a lens which focuses the laser beam onto the ablative target material. Ablation of the target material occurs and a series of combination follows as the laser beam continues to focus on the ablative target material. Now I will present on the different T and R mode. In T mode, high intensity beam is focused onto ablative target material. Plasma jet is produced on the opposite side of target material, as can be seen in the figure above. The top part of the figure is the R mode. In R mode, plasma jet is produced on the same side of the incident high intensity laser beam instead. So the main difference between R mode and T mode is that in T mode there is another layer on top of the ablative surface. We have a transparent substrate which stops the plasma jet from flowing back. T mode offers better protection in this sense. However, R mode offers better specific impulse and coupling coefficient. What is the coupling coefficient? The coupling coefficient is the ratio of momentum thrust over laser energy used. Let me now explain and present the evolution of the state-of-the-art technology for micro LEP. Initially, only a single pulse of laser beam is used. However, this was not enough to produce sufficient thrust. Hence, multi-pulse laser beam with ND-YAG laser of about 1064 wavelength nanometer and pulse width of 20 microseconds was used. As a result, thrust increased. To further increase thrust, magnetic field was introduced using a superconducting magnet of about 4.5 Tesla. Laser beam from ND-YAG laser 1064 nanometer was also used with a pulse width of 10 ns. Pulse width. As a result, thrust increased by a factor of 2 using the magnetic field. Why do people or researchers always use ND-YAG laser at 1064 nanometers? Firstly, it is because it can be used in pulse or continuous mode, and secondly, because from the figure, as you can see from the figure here, it has the ability to produce the highest incident fluence for single mode or multi-mode diodes. Let me continue back to the evolution state of the art of technology for micro LED. Next, PVC was often used as target material. However, PVC as target material has low ablative efficiency. As a result, a study was suggesting using exothermic material designed so that lower laser energy is required to generate the same plasma jet. Next, aluminum foil was used whereby a thickness of 12.5 micrometer yielded optimum thrust. The shape of the beam was also researched and analyzed in respect to micro LED. It was decided and it was found out that the beam shape of rectangular beam shape generated more thrust than a beam shape of the normal circular beam. However, this rectangular beam is only effective for pulses more than 1 microseconds. And currently, trends have been researching on nanosecond pulse for higher intensity. As a result, less fluence, about 500 times lesser, is needed to generate the same plasma thrust. Now I will compare the different performance metric between micro LED and other form of in-space propulsion technologies. As can be seen on this table here, micro LED generated the best thrust compared to other small thrusters. We exclude iron and Hall thrusters as they are very big in size. However, if one needs specific impulse or if a specific space mission requires higher specific impulse, then nano LED is better at it than micro LED. However, in general, micro LED has the best performance or the best potential performance across other micro small thrusters. There are several commercial companies involved in LED over the years. For example, EMS Technologies have been producing digital scanners for universities and research centers that are researching on LED. These digital scanners are used to change the direction of laser beam. Another company is known as Concepts Research Incorporated. Concepts Research Incorporated produces or designs microchip lasers for LED usage. Another company or well-known company is Photonic Associates LLC. They have been given funding by NASA over the years to manufacture different kinds of laser-induced micropropulsion. These are the references. Thank you so much. If you have any question, please email me at abdul_halim@mymail.sutd.edu.sg. Thank you.